Hello, hello. So we're going to talk about Stackelberg model of competition. It's again a duopoly. It's kind of similar to Cournot in the sense that it's two firms and they are having this duopoly and they are choosing quantities. Their actions is quantities. Okay, what the firms do, they choose the quantity and the price adjusts given the demand. Okay, so let's see in this case here, set of players, firm 1, firm 2, 2 players, inverse demand, price equals 1 minus aggregated quantity. Aggregate quantity is the quantity of firm 1 plus quantity of firm 2. I'm assuming zero costs to make the model a little bit easier. If you have costs, it's basically similar. And the profit of each firm is the price times quantities, just the revenue. Zero cost, right? Is revenue minus cost, the profit in general. But because I have zero cost, it's just the revenue. Now, the timing of the game is as follows. That's the difference from Cournot. In Cournot, remember, firms move simultaneously, but not here. In Stackelberg, firms will move sequentially, one after the other. So firm 1 moves first, chooses the quantity of firm 1, Q1. Firm 2 observes Q1. So firm 2 see, aha, they play that, they cannot change anymore. Now it's my turn to choose. So firm 2 moves second by choosing the quantity Q2. Okay? And at this point you might think, oh, it's unfair. Why one firm would have to move first and the other move second? Probably the firm that moves second has more information and will do better. Huh? You could think that. If you don't know, if you are not an economist, you might have this, oh, they have more information, therefore they are better off. You could, right? Luckily you're an economist. So the solution, the equilibrium concept is going to be subgame perfect equilibrium, which is a refinement of Nash equilibrium. The solution is by backward induction. So assume that the quantity of firm 1 is Q1, is fixed. And now let's analyze the problem of firm 2. Firm 2 wants to maximize its profit. Q1 is already given. Q1 is a given number. Firm 2 maximizes its profit by choosing some quantity Q2, non-negative. Perfectly divisible good again. This is the price, 1 minus the aggregated quantity, that's the price, times the quantity of firm 2. Okay, so that's the total revenue, and also because costs are 0, the total profit of firm 2. So we solve it, we write this profit of firm 2 as a parabola. If Q2 is 0, this is 0, we are here. If Q2 is equal to 1 minus Q1, then this is 0, and we are here. Because it's a parabola, the maximum, the vertex of the parabola is right in the middle between 1 minus Q1 and 0. So the best reply of Q2 is 1 minus Q1 over 2. Assuming Q1 is smaller than 1, okay? So that's how firm 2 will play its best reply. It will make 1 minus Q1 divided by 2. Okay? Now, we move one step back. We move back to the first period. Firm 1 anticipates this kind of behavior by firm 2. Anticipates this is going to be the best reply of firm 2. Remember, players are fully rational in the model, right? So firm 1 maximizes its profit, knowing that Q2 is going to be a function of Q1. If firm 1 plays a large quantity, this number goes down, right? This is a decreasing function of Q1. So firm 1 understands that and incorporates that in its decision. The profit of firm 1 is price times quantity of firm 1. So this is going to be price, this is the quantity of firm 1. Price is 1 minus Q1 minus Q2. This is Q2. Is this. Look what nice trick here. Okay? So this chunk here, this is the Q2. So doing some algebra here, I can express this, as minus Q1 over 2, Q1 minus 1. Okay? And I do the graph here, Q1 and profit of firm 1 as a function of Q1 only. If Q1 is 0, I'm here. If Q1 equals 1, I'm here. And the maximum is right in the middle. Between 1 and 0 is 1/2. Okay? That's the optimal action for firm 1. So firm 1 will choose half. Okay? And firm 2 will apply its best reply. So 1 minus 1/2 is 1/2 over 2 is 1/4. So firm 2 will choose 1/4. The aggregate quantity in equilibrium, it's going to be 3/4, and the price 1 minus 3/4 is 1/4. Okay? The profit of firm 1, firm 1's profit is price times Q1. So it's going to be 1/4 times 1/2, 1 over 8, the profit of firm 1. The profit of firm 2 is price times Q2, 1/4 times 1/4 is 1 over 16. So notice firm 1 has more profit than firm 2. Whoa! That could be a bit surprising, right? So firm 1 profit is larger than firm 2. What's going on? So firm 1 chooses the same quantity as a monopolist would in this situation. And firm 2, it inundates the market. It says, wow, I'm doing this much. Knowing the price will be pushed further down because firm 2 will also produce some quantity, but it's the best, right? We do the calculation, that's the best firm 1 could do. So here I have a diagram comparing the outcomes in this market when we have this and zero costs and this inverse demand. The monopoly would choose aggregate quantity 1/2 and the price would be 1/2. The monopoly profit would be 1/4. So the monopoly profit would be bigger than the Stackelberg leader. Firm 1 is called the leader and firm 2 is called the follower. The leader because it moves first and the follower because it moves second. So this is the model that explains the first mover advantage, or the advantage of the first mover. It refers to the fact that the profit of firm 1 is bigger than the profit of firm 2. So firm 1 behaves as a monopolist, chooses one quantity 1/2 and leaves just a residual demand, just a little part of the demand, those consumers who are not willing to pay more than 1/2, and firm 2 behaves as a monopolist over the residual demand, over what's left over of the demand, and chooses the middle between this point and this point, right? This is right in the middle of this segment here. 3/4 is the middle between 1/2 and 1. So the follower behaves as a monopolist over the residual demand. Okay, and comparing the outcome of the monopoly, the Cournot outcome, the Stackelberg outcome, and the perfect competition outcome, we can rank that in terms of welfare, right? The perfect competition has the highest welfare, then the Stackelberg model has the second highest welfare, then we have the Cournot model, and the more inefficient scenario is the case of a single price monopoly. Okay, the single price monopoly is horrible in terms of welfare. It's the worst of them all. Okay, so in the Stackelberg model, what's the equilibrium? What's the subgame perfect equilibrium of the model? Well, for firm 1, an action is a strategy. So the action Q1 star equals 1/2 is the entire strategy. That's all the firm 1 can do. Choose whatever you do because it goes first. For firm 2, an action is different from a strategy. Now, action is one thing, strategy is a different thing. The strategy of firm 2 is the entire function, the best reply. Okay? It's the entire function. It describes how it will do even in continuation paths that are not in the equilibrium one. It describes the entire behavior of firm 2 as it would be in all situations that player 2 might be called upon to play. Okay, so this is not the quantity, that's a function. And the strategy of player 2 is this function. Okay, the strategy of player 1 is just the quantity, an action. So for player 2, actions and strategy are different objects. Okay. Well, I think that's it. Very famous. This model was made in the 1930s, so almost 100 years after Cournot model, but still incredibly clever model. Noticing that the timing of the game can change the outcome, right? If it was a simultaneous move games, it would be Cournot. We wouldn't appear because it's a sequential game. We have a different solution. Okay, it's very subtle. Even advanced students sometimes mix up Cournot with Stackelberg. So be careful. The timing, the rules of the game can change the outcome in a drastic way. Okay, so Stackelberg model of competition, duopoly model again, sequential moves. Hope you enjoy. See you guys next time. Bye bye.